presented the concept of absolute value in the previous lesson, okay? So in our today's lesson, we will see the comparison and ordering of rational numbers, okay? Comparison of rational number, okay? So the first point of discussion for today's lesson is about comparison of rational numbers. Then after we will see ordering of rational numbers, okay? So as you all know, rational numbers can be given in different forms, in decimal form and in fractional form, okay? So the first point of discussion under this topic is comparison of decimals, okay? Comparison of decimals. All right. Comparison of decimals can be done like the way we compare other numbers, okay? Whenever we have decimals, the first thing that we do is we compare the integer part first. If the integer parts are the same, we keep comparing the tens digits. If the tens digits are the same, again, we compare the hundreds digit, right? So this is how we compare decimals. For example, compare the following decimals. Here we have different decimals. The first decimal is 8.73 and 11.34. Okay, these two numbers are rational numbers which are given in decimal form. Okay, here if you are asked to compare these two decimal number, the first thing that you need to do is comparing the integer parts. All right, okay, as you can see here, the integer part for the first decimal is 8, and the integer part for the second decimal is 11. So clearly 8 is less than 11, so we don't compare the tens and the hundreds digit. We stop here and we write 8.73 is less than 11.34, okay? So this is how we compare decimals, okay? Sometimes we may have decimals having the same integer. For example, suppose we have 4.39 and 4.25, okay? Here, these two are decimals where their integers are the same, okay? 4, 4, okay? In this case, you compare the tens digit, okay? Here, the tens digit for the first decimal is 3, and this one is 2. Since 3 is bigger than 2, we say that 4.39 is bigger than 4.25, okay? This is how you compare whenever you have two decimals having the same integer. The other example can be, say, we have 10.349 and 10.324, okay? Look, whenever you are asked to compare these two decimals, you need to see the hundreds digit because their integer parts are the same, their tens digits are the same. So the next thing that you need to do is you need to compare the hundreds digit, okay? So the hundreds digit for the first decimal is 4 and this one is 2. Since 4 is greater than 2, we stop comparing here. So this 10.349 is bigger than 10.324, okay? So this is how you compare decimals, okay? Next, we will see how to compare fractions. Okay. Comparing fractions. Okay, in comparison of fractions, you may have fractions having the same denominator or different denominators, okay? So here we will see the different cases. The first case is comparison of fractions with the same denominator, okay? Comparison of fractions with the same denominator, with the same, usually positive denominator. Okay, in this case, I want to tell you some general procedure on how you can compare fractions having the same positive denominator. Suppose we have two fractions, a over b, and c over b, where this b is positive. Okay, here, as you can see, these two fractions are fractions having the same denominator. In this case, we can say that a over b is greater than c over b if and only if this condition happens. That condition is a should be bigger than c, okay? So a over b is bigger than c over b whenever a is greater than c. If the inequality is given in this form, a over b is less than c over b, this happens only whenever a is less than c, okay? The two fractions will be the same, a over b and c over b will be the same whenever these a and c are the same. That is the procedure to compare fractions having the same denominator. Let's see some example. Compare the following fractions. Compare the following fractions. The first example is, say we have a fraction 3 over 5 and 11 over 5. Or the second example is minus 2 over 7 and 1 over 7. Say we have a certain mixed numbers such as 2 and 3 over 4 and 3 and 1 over 4. Okay, let's see these examples. In all these examples, we have fractions having the same denominator. All right. So whenever you are asked to compare these two fractions, as we have said here in these principles, a over b and c over b can be compared using these principles. Okay, so whenever we come to the first example, we have 3 over 5 and 11 over 5. All right, so these two fractions are fractions having the same denominator. So we follow this principle, the first principle, okay, the principle that we have here. So 3 over 5 is definitely less than 11 over 5 because 3 is less than 11, okay? So in this case, we will have 3 over 5 is less than 11 over 5 because 3 is less than 11, okay? When we come to the second fraction, they have the same denominator, so we compare the numbers on the numerator. So here the numerator is minus 2 and here 1. since minus 2 is less than 1, definitely this fraction will be less than 1 over 7. So your answer will be minus 2 over 7 is less than 1 over 7 because minus 2 is less than 1. When we come to the third fraction, these two are mixed fractions. So the first thing that you need to do in comparison of this mixed fraction is you need to change these mixed fractions into improper fractions. Okay, so the improper fraction form of 2 and 3 over 4 is 11 over 4. And the second mixed fraction, 3 and 1 over 4 is 13 over 4. Okay, students, we have seen how to convert mixed fraction into improper and vice versa. Okay, this was what we have seen in the first period. Now, we are going to compare these two. So we changed this mixed fraction into improper fractions in this way. So now, the only thing that is left is comparing their numerators. So as you can see here, the first number, here 11, and here 13. Since 11 is less than 13, this comparison will be given in this form. 11 over 4 less than 13 over 4. So you can say this number is less than this, okay? Sometimes without doing all this thing, you can simply compare their integer part, okay? If their integer parts are different, since 2 is less than 3, definitely this mixed fraction is less than the second one. So this is how we compare fractions having the same denominator, okay? So next we will see how to compare fractions with different denominators. Fractions with different denominator. So usually you can have fractions, 2 or more fractions with different denominators. So let's say we have 2 fractions, a over b and c over d, where their denominators are non-negative numbers. Say d is greater than 0 and b is greater than 0. That means whenever we have fractions with positive denominator and different denominators, we will have different ways of comparison. Okay, there are 2 different ways of comparing fractions. Okay, the first method is, say method 1. In method 1, we can convert these fractions into equivalent fractions in a way that these 2 fractions have the same denominator. Okay, since b and d are different, you can calculate the LCM of the denominators. Okay, so using the concept of LCM, we can create similar denominators. So I will show this thing using example. For example, compare the following fractions. So the first example that we have here is compare 1 over 2 and 2 over 3. Okay, as you can see here, these 2 numbers are fractions having different denominator. In this case, I will show you what you need to do to compare these 2 fractions. Look, the denominator of the first fraction is 2, and the denominator of the second fraction is 3. So what you need to do here is you need to take the LCM of 2 and 3. Okay? The first thing is take the LCM, okay? The LCM of the denominator 2 and 3 is 6. This is a concept from the previous grade level. So we have the LCM. So we need to convert these two fractions into a fraction having the same denominator. So 1 over 2 can be equivalently expressed as 1 over 2 times 3 over 3. All right. Multiplying any number by positive 1 will not affect the quantity or the value of the number. So without loss of generality, you can do this way. Why do I multiply by 3 over 3? Just to convert these two into 6, okay? So this becomes 3 over 6. Again, take the second number, 2 over 3. 2 over 3 can be equivalently written as 2 over 3 times 2 over 2. This result becomes 4 over 6. Okay, now we have their equivalent form. 1 over 2 is exactly 3 over 6. 2 over 3 is exactly 4 over 6. Okay, so based on the method that we have seen before, you can easily compare these two fractions. These two fractions are fractions having the same denominator. Since 3 is less than 4, definitely we can say 1 over 2 is less than 2 over 3. Okay? Since 3 over 6 is less than 4 over 6, by transitivity, this means 1 over 2 is less than 2 over 3. Okay? This is the first example. Let's see some other example. 3 over 4, compare 3 over 4 and 5 over 7. Okay, so if you want to compare these two numbers using the method that I used here in A part, you can convert these two numbers into fractions having the same denominator. So to do this, we need to take 4 and 7 and determine the LCM of the two numbers. Okay, so what is the LCM of 4 and 7? The LCM of 4 and 7 is 28. Okay, the LCM of these two numbers is 28. So we need to convert these two fractions into their equivalent fractions where their denominator is 28. So we do this thing in this way. 3 over 4 can be written as 3 over 4 times 7 over 7. This gives us 21 over 28. Okay? Take 5 over 7. 5 over 7 can also be written as 5 over 7 times 4 over 4. And this gives 20 over 28. Okay? Now, we have converted these two fractions into equivalent fractions where their denominators are the same. Now, it's very simple to compare these two fractions. 21 over 28 and 20 over 28. So, as you can see, 21 is bigger than 20. So, this tells us 3 over 4 is bigger than 5 over 7. So, from this, we get that 3 over 4 is bigger than 5 over 7. Okay? So, this is how we compare different fractions having different denominator. Okay? This is one method. Okay? I will show you the other method of comparing two or more fractions. Okay? Now, let's see the second method. So the second method is sometimes we call it the cross product method. The cross product method. Okay. Let's say we have two fractions, a over b, and c over d, where b and d are positive denominators. B and d are positive denominators. We usually prefer the second method. I will show you what this second method looks like. Okay, so in this case, if a over b is greater than c over d, this tells us a times d is bigger than b times c. Okay, this is the principle. Okay, if this inequality is reversed, here the inequality will be reversed. If this becomes equal sign, then this product will be equal, right? So shortly, a over b is bigger than c over d if and only if a times d is bigger than b times c. And the third thing here is a over b is equals to c over d if a times d and b times c are the same. Okay, I think this is the preferred method in comparing two or more rational numbers. Okay, so let's see some examples on how we can apply this method. For example, compare the following fractions. Okay, the first part, take 2 over 3 and 3 over 4. Okay, if you are asked to compare these numbers, okay, we take the cross product, okay? Compare 2 times 4, okay? 2 times 4 and 3 times 3, okay? Since 2 times 4 is 8 and 3 times 3 is 9, definitely 8 is less than 9. So this comparison gives us 2 over 3 is less than 3 over 4. Okay, this is the preferred method. Let's see some more examples on this concept. Take another fractions. Let's take some mixed fractions. 5 and 1 over 2 and 5 and 4 over 7. So whenever you are asked to compare these two fractions, you don't need to convert this mixed fraction into improper fraction. You don't need to take it. Since their integer parts are the same, we don't need their integer part. We take only the improper fraction part. We take 1 over 2 and 4 over 7. So take 1 over 2 and 4 over 7 and take the cross product. So we multiply 1 with 7 and 2 with 4. So taking the cross product, this gives us 1 times 7 and 2 times 4. Since 1 times 7 is 7 and 2 times 4 is 8, clearly this is less, okay? So whenever you are asked to compare this fraction, you need to write 5 and half is less than 5 and 4 over 7. Okay, this is the second method of comparing rational numbers, okay? Usually rational numbers with different fractions. Okay, next we will see how to order 2 or more rational numbers, okay? Particularly writing a certain rational numbers in ascending order and in descending order. This is our next point of discussion. Okay, already we have seen how to compare two fractions having the same denominator and having different denominators. So next we will see ordering of 2 or more fractions and decimals, okay? ordering of rational numbers. So when we come to this topic, rational numbers can take different forms. It can be expressed in decimal form or fraction form. So we will see how to order rational numbers which are given in decimals, okay? Comparing decimals. Okay, when we come to comparison of decimals, we usually apply the procedure that we used for comparing another numbers, okay? Comparison of decimal can take the principles that are used in comparing other numbers, okay? So let's see some examples on how we can compare decimals. Example. Compare the following decimals. So the first example is if we have 9.25 and 11.37, okay? If we are asked to compare these decimals, definitely 9 is less than 11. Their integer part is less. So you can write 9.25 is less than 11.37. Okay, this is comparison. Okay, students, we have seen how to compare rational numbers which are given in different forms, such as comparing decimals, comparing rational numbers which are given in fractional form, such as comparison of rational number having the same denominator, comparison of rational number having different denominators, and we have seen also the different ways of comparison. For example, we have seen how to compare two or more rational numbers having the same denominator using the LCM method, and we have also seen how to compare two fractions having different denominator, okay? So based on the discussion that we have today, I have a certain homework for you. Here we go. So the first question that I have for you today is compare the following decimals. The A part, in A part, we have negative 10.78 and negative 19.32. The second one in comparison of decimals is 8.25 and 8.39. The third one is 5.349 and 5.324. Okay, this is the first question for your homework. The second question is compare the following fractions. The A part, in A part, we have 6 over 11 and 3.5. In B part, the absolute value of minus 3 and 3 over 4 is equal to and 7 over 9. the C part, 11 over 19, and 10 over 19. Okay, these are your homework for today. I hope you enjoyed the lesson. Thank you for listening.